I have two eggs in my hand, two eggs of equal mass, okay? Two identical eggs, they are having same mass, but there is a difference. Difference is, one is a raw egg and the other is a boiled egg. Identical in mass, same size, same mass, only difference is one is a raw egg and the other one is a boiled egg. Okay, now what I'm doing is, I'm going to drop these two eggs from the same height. Okay, from the same height, I'm going to drop these two. Okay, so I'm going to ask you a very simple question. Which egg will touch the ground first? Is it raw egg or boiled egg? Remember, mass is same, size is same, identical, difference is raw egg and boiled egg. All of you know the answer for this question, right? Because you know that acceleration of a body, acceleration of a freely falling body is independent of the mass, independent of the shape, independent of mass distribution, right? For all the objects, acceleration due to gravity is same. So ignoring the air resistance, you know that acceleration is same. So both raw egg and boiled egg will reach the ground in the same amount of time. So that's a very simple question. So please note that acceleration due to gravity is independent of mass, size, shape, mass distribution, everything. But when you are thinking about, I'm taking that these two masses again, these two eggs again. Remember, one is a raw egg and other one is a boiled egg. And what I'm going to do here is, these two eggs, see, let it be an inclined plane. There is an inclined plane. So from the top of this inclined plane, look, this is the ground. From the top of this inclined plane, I'm going to release these two eggs from the same time, raw egg and boiled egg. So all of us know that it is not a free fall, it will roll down, right? And it will reach the ground. So I'm asking my question again, which egg will reach the ground in shortest time? Is it raw egg or boiled egg, or both of them will reach in the same time? What do you think? Same? Raw egg or boiled egg? Dear students, welcome to yet another physics session for Brilliant Qatar. Today we are going to discuss a topic from rotational motion, that is nothing but rolling of a body without slipping. You'll get the answer for this question. Which one will reach the ground in shortest time? After some time. So let's directly go to the topic. Listen. So let's, for a time being, we can leave raw egg and boiled egg. Instead of that, what I'm taking is a ring and a disc. A ring and a disc of same mass, same radius. Everything is same. So only difference is one is a ring and other is a disc. So listen here. Look at this. Let it be the ring. You can take its mass as m, mass of the ring as m, and its radius is r. And I have another object that's a disc, but it is also having the same mass, same radius. You know what is the difference between a ring and a disc? It's only in the mass distribution, right? On a disc, the mass is distributed everywhere. But ring means it is only at its rim. Please note that their mass is same, their radius is same. And I'm going to release these two, the ring and a disc, from the top of an inclined plane. Both will reach the ground. Who will reach in the shortest time? That's what we are going to discuss now. And after that, we will go back to our question, raw egg or boiled egg, which one will reach the bottom? Okay, so listen. For that, let us take an inclined plane. See, this is the ground. That means we will call it as the horizontal position. This is the horizontal plane, horizontal surface, and on which I am going to arrange an inclined plane as well. Look at this. You can see a plane is arranged at some angle, right? That angle is our choice. So let us take that angle of inclination as theta. And from the top of this inclined plane, I am going to release ring, disc, sphere, a hollow sphere, solid sphere, cylinder. Cylinder is also of two types, you know that. Hollow cylinder, solid cylinder, anyone which can easily rotate. So I'm not going to specify the body here. You can assume anything, ring, disc, whichever you want. Okay, so I'm just going to draw its shape. Look at this. It's a sphere, spherical, right? If you're looking from this side, clearly it will be a spherical body. Look at this. This is the body. I told you it can be a ring, it can be a disc, it can be a sphere, it can be a cylinder, anything. So we are looking from this side. For us, it will be just, it appears like a circle. Okay, now we need to mark some parameters here. One is the mass of this body, as usual, m. Mass is m, and the radius. Radius, I'm going to take it as r. Okay, so there is an object which is rolling down an inclined plane. Its mass is m, its radius is r. Okay, everything clear now? Now, if m is the mass of the body, what will be its weight? All of us know that if mass is m, weight will be mg, right? And what is the direction of the weight? Weight is always acting towards the center of the earth. That means it is vertically down. And you know that weight is a vector quantity. So we can show it using a vector. Weight is a vector. Look at this. The weight of the body is always acting down. Yeah. This is the weight and it will be mg, right? Weight will be mg. Okay. Mass is m, weight is mg, which is acting vertically down. Now, I'm going to use the idea of resolution of vectors. You know, any vector can be resolved into two mutually perpendicular vectors, rectangular components, right? So, I'm going to resolve this mg. You'll understand the purpose after some time. I'm going to resolve mg into two mutually perpendicular components. So, which are the two components? You can see the components will be, one will be the vertical component, that means the sine component, and other will be the cos component, right? So this is one component and the other one will be like this. Okay. So these are the two mutually perpendicular in the sense you can see that they are the rectangular components, right, of mg. Now we need to write the magnitude of these components. This angle is theta, this angle will be 90. So this will be 90 minus theta. So of course this angle will be theta, right? So if this angle is theta, this angle will also be theta. So definitely this will be the cos component, right? This is mg cos theta and this will be what? Mg sin theta. Mg sin theta. Okay, so in this diagram, see, weight is mg. We are just resolving into two components. One is mg cos theta and another is mg sin theta. Now, I'm going to mark the normal reaction as well. What is mean by normal reaction? You know that it is a reaction perpendicular, normal to the surface, right? So here the surface is like this. So how can I mark the normal reaction? Normal reaction will be normal to that surface. So we can show it like this. This will be the normal reaction, right? And that normal reaction can be marked as n, and clearly you can see that from the diagram that n is equal to what? Mg cos theta. N is equal to mg cos theta. In this direction, mg sin theta is acting. Right. Apart from this, can you mark any other force on this body? We have used the idea of weight, normal reaction. Everything is marked here. One more will be there, right? That is nothing but the friction. Friction will be there. And what will be the direction of friction? Friction is always opposite to the applied force, right? So here the force is acting in this direction. So body have a tendency to move down. So friction will be acting in opposite direction. And students, please note that friction is always tangential to the surfaces in contact. Friction will not act to the center of the body. It will be tangential to the surface in contact. So here check the diagram. Which are the two surfaces in contact? One is this inclined plane and other is the surface of the body. So if you're asked to mark the direction of friction, it will be this way. This is the direction of friction. We can take its magnitude as F. I hope the diagram is very clear. So all the forces is been marked. You can see weight is mg, mg cos theta is there, mg sin theta, they are the components of mg, then the normal reaction N and the frictional force F. Clear now? Right. Now the first step of this discussion is we have to write the equation of motion. Equation of motion. How to write the equation of motion? For writing the equation of motion, you have to find the net force. Net force means vector sum of forces acting on this body. That's very simple. Listen, the body is moving in this direction, right? It's rolling down. In that direction, which force or which all forces are acting in that direction? That you can easily understand. There is only one force which is acting in this direction. What is it? Mg sin theta. So mg sin theta is the force that is pulling the body down. Then you have to check, is there any force opposing that motion? right? mg sin theta is acting in this direction and friction is acting in opposite direction, right? So these are the two forces which determines the body's motion, right? And what will be the net force? Here, net force, how can you find? The bigger one minus smaller one, right? So we have two forces, mg sin theta and F, which is bigger one. That also you can easily understand. The body is rolling down, right? It's not going in upward direction, which means mg sin theta is greater than F. So what will be the net force? Net force will be mg sin theta minus F. Is it clear or not? mg sin theta minus F, that is a net force. So we will start from that formula. I'm going to write it here. Net force F net is equal to mg sin theta, which is acting down, mg sin theta minus the force of friction, F. mg sin theta minus F. Okay, now all of us know that. What is the basic formula for the net force acting on a body? According to Newton's second law, you know that force is mass times acceleration, right? So for the net force, we can write ma. So ma is equal to mg sin theta minus F. What is A here? A is the acceleration of the body. That's what the quantity we have to determine. Based on that quantity, we can say that which body will reach in the shortest time. So A is the acceleration of the body. So ma is equal to mg sin theta minus F. Okay, where F is what? Friction. Take it as equation number 1. Clear? Right. Now we have to find the frictional force. How can we find the friction? For that, we can use the idea. Listen, all of you here. Body is rolling. It's not sliding, right? The body is rolling. We know that for a body to rotate, there should be a torque, not a force. Please note. Forces acting on a body doesn't mean that the body is rotating. For there is a rotation, there should be a torque. What is torque? Torque is the rotating effect of force, right? Rotating effect of force. Some forces can make the body to rotate. So here total you can see many forces are there. mg cos theta, mg sin theta, n, f. So I'm asking you a question. Out of these forces, which all forces or which force can provide torque? Just use your idea of torque. Which all forces can provide torque on it? mg cos theta, mg sin theta, n, f. There is only one force which can provide torque. What is that? It is nothing but friction. Why? What is the reason why? There are many forces, right? But only friction can make the body to rotate. The reason is, if you are looking at the diagram, the vector representation, you can see that apart from friction, all other forces are acting at the center of the body. Center of the body is axis of rotation, right? A force which is acting at the axis can't make a body to rotate. Because in the formula for torque, there is, you know, that Rf sin theta. If you are applying force at the center, R value will be 0. Very simple idea. You can't open or close a door by applying force on its axis, right? So if a force is acting on the axis, it can't make the body to rotate. So let us conclude there is only one force which can provide torque. What is that? F. So now we can easily find the torque. Okay. So I'm going to the torque equation. Listen. Torque. Tau is equal to, what is the formula for torque? Torque is equal to magnitude of force into the perpendicular distance between line of action of force and axis of rotation. All of you know that formula, right? So torque is equal to magnitude of force. Which force? Friction. So friction into what? Perpendicular distance between line of action of force. See, this is the line of action of friction, right? Line of action of friction. And where is axis of rotation? Axis of rotation is the center of the body. So this is the center. So what is the perpendicular distance between this center of the body and the line of action of force? So that is nothing but this distance, that is equal to the radius of the body, right? That is R. So we can write torque is equal to FR. FR. I think it's very clear. The torque acting on this body is F into R, where F is the friction and R is the radius of the body. Take this as equation number 2. Okay, now I'm going to another basic equation for torque. All of you know that torque acting on a body is given by, we have another formula for torque. What is it? It's I alpha. Take it as equation number 3. Torque is equal to I into alpha. What is I? I is the moment of inertia of the body, right? And alpha is angular acceleration. So torque is equal to I alpha. So if you're comparing these two, comparing equations 2 and 3, LHS is the same, so you can equate the right hand side. So what we get, FR is equal to I alpha. FR is equal to I alpha. So F is equal to I alpha by R. This is the force of friction acting on this body, right? I alpha by R. Now we have to make some more changes here. What is I? Moment of inertia, right? What is the formula for moment of inertia? We can't answer that question because without specifying the body, how can we know the moment of inertia? If it's a ring, you know that it's mr square, right? But for disk, it is mr square by 2. For hollow sphere, it is 2 by 3 mr square. Solid sphere, it is 2 by 5 mr square. Here, I did not specify which body it is. So we have to use the general formula, right? What is it? It is mk square. The general equation for the moment of inertia is mk square. So I'm going to write that mk square. What is k? Radius of gyration, right? You know what is radius of gyration. So mk square, and R is already there, into alpha. What is alpha? Alpha is angular acceleration, and you know that angular acceleration is equal to A by R. This is another familiar result, A by R, where A is the linear acceleration. So we get mk square by R into A by R. So rearranging, what we get, it will be m into A into k square by R square. K square by R square. This is the friction. M A into k square by R square. Clear? Right. So we got the value of force of friction acting on this body. It is ma into k square by R square. M is mass, A is acceleration, K is Z, radius of gyration, and R is radius. Now you can substitute that value of friction in equation number 1. Okay, so let's go back to equation number 1. Let's see what's the result. It is MA, left hand side it's MA equal to mg sin theta, mg sin theta, mg sin theta minus F. What is F? F is MA into K square by R square. So what was our aim? Our aim is to determine the value of acceleration, right? So take this MA to minus MA K square by R square to this side. So we get MA plus MA into what? K square by R square is equal to mg sin theta. Mg sin theta, right? Okay. So here MA is common, take it out. So it will be MA into 1 plus K square by R square, right? 1 plus K square by R square equal to mg sin theta, equal to mg sin theta, mg sin theta. So from this m is common, will get cancelled. We need to find A. So A is equal to what? Look at the result. It is g sin theta divided by 1 plus K square by R square. This is our required result. Acceleration of a body which is rolling down an inclined plane is equal to what? G sin theta by 1 plus K square by R square, right? Formula is fine, but still the question is how can we find the idea like which body will reach the bottom first. I'll explain it. Come back to this equation. A equal to G sin theta by 1 plus K square by R square, right? So here you can see that acceleration depends on G. It's not in our hand. It's a constant, right? Sin theta. Okay, once an inclined plane is set, theta is constant. 1 plus K square by R square. Not that. K square by R square. What is K? It is radius of gyration. What is R? Radius. So K square by R square is the factor that determines the acceleration. So we have to check which body is having more value of K square by R square, right? It is in the denominator. So if K square by R square is more, acceleration will be less. If K square by R square is less, acceleration will be more. How can we find it? Very simple. We can take a ring and a disc. I'll show you with the help of ring and disc. That was our question. Ring or disc, which one will reach the bottom first, right? So ring, disc of same mass and same radius, right? Same mass and same radius. Recall the moment of inertia formula. What is the moment of inertia of a ring? Moment of inertia of a ring is mr square. Mr square. Moment of inertia of a disk is what? Mr square by 2. Or we can write it as half mr square. Moment of inertia of a ring is mr square. That of a disk is half mr square. Now, what is the general equation for moment of inertia? For any body, it is mk square. So left hand side I can write mk square. That's a general equation. Mk square. Look, m will be cancelled. M will be cancelled. Here what is k square by r square? K square by r square will be 1. And comes to here, k square by r square will be half. Look at this. So what we are getting is, for a ring, k square by r square is 1. For a disk, k square by r square is half. Tell me, which body is having more value of k square by r square? It's for ring. Ring, k square by r square is 1. Look at the equation. K square, more the value of k square by r square, acceleration will be less. Less the value of k square by r square, acceleration will be more. Now tell me, which body will be having more acceleration? Is it ring or disk? Clearly we can say that disk is having more acceleration because its k square by r square value is small. So disk will reach the bottom in the shortest time. Clear? I think it's perfect. Before concluding, let's go back to our first question. What was it? A raw egg and a boiled egg. Which one will reach the bottom first? Very simple. If you're comparing the moment of inertia, you can see that which is having more moment of inertia. Ring. Ring is mr square, disk is half mr square. And we have already got an idea that disk will reach the bottom first. That means small the value of moment of inertia, more the value of acceleration, right? So basic question is raw egg or boiled egg, which is having less value of moment of inertia, right? Less value of moment of inertia, then that will reach the ground in the shortest time. So think about a raw egg and a boiled egg, make it rotate. Boiled egg means it's pure solid, mass is distributed everywhere. Raw egg means it is inside, it will be in liquid form. So when you're rotating, the liquid will move to the side. So just like a hollow sphere, that means its moment of inertia will be more. Boiled egg means it is in solid form, so it's just like a solid body, like a disk. Mass is distributed everywhere, right? So its moment of inertia will be less. So less moment of inertia is for which body? It is for the boiled egg. That means less value of k square by r square is for boiled egg. More value of acceleration will be for the boiled egg. So which egg will reach the ground in the shortest time means it is the boiled egg. Boiled egg will reach the bottom first. Okay, so I hope this topic is very clear. Thank you very much.